Okay, here we go. So yesterday when we talked about this, we wrote it down. I want to remind you that A of t is what you either have left over or what you have altogether. So it just depends on, A of t just depends on whether it's decay or growth. This one is a growth model because 1 plus R. R being your rate, they'll give it to you. A being the initial value. So they're going to give you initial value, a starting point, okay? And then T is the time, which would be your exponent. Okay, so we're going to look at example 4. Teen spending, a little bit, there we go. Teen spending is expected to grow 3.5% annually from $79.7 billion in 2006. Draw a graph to show the spending growth. So that means right there, we know we have a growth model. Before you can graph it, you have to come up with an equation. You can't graph anything without an equation. So we're going to start with A of t. And we're just going to write the basic equation down so that we know that indeed we have a growth model. Okay, so A of t stays. That's what we're looking for. Okay, that's going to be our answer after so many years. The lowercase a means initial value or initial amount. So what is our initial amount in this problem? How much money are we starting out with? Yep. Then it's 1 plus, what is our rate? So how do we write that as a decimal? .035. Remember to write it as a decimal, you move it 2 places to the left. And then t is our exponent. So that's our equation. From there, we now can make a table and do our graph. So to do that, let's just go ahead and make a table. So we're going to have t, which is our time is in years. And then we're going to have A of t, which is, sorry, I didn't need that. A of t, which is our amount after so many years. Because we're dealing with money, we're dealing with years, our t, our first exponent is going to be 0. Because that's our initial amount. So it's kind of like when you deposit. If you put $5 in the bank, you start with $5 and then it goes up from there. So at 0 years, how much was our value? We already know this. We already know this one. At 0 years, how much was our value? 79.7. And then we're just going to go 1, 2, 3, 4. We're going to do 4 years. So now we're going to plug in 1. So to plug in 1, even if you have, you guys, you really need to start using those parentheses, okay? I'm going to hit equals and let's see if we all got the same thing. Is that what you got? Okay, so now we have our ordered pairs. Now, down here, this is going to represent the number of years. So this is our t, or our x value. This is the one that we plugged in, okay? And then this side right here is going to be spending and we're going to put billions. Okay. This will be 0. We're going to put a little break in. And we're going to start with 80, 90, 95, and then we'll do 100 up here if we need it. And then we'll do 1, 2, 3, 4. You guys, I do believe that's a little bit easier when you have a grid to graph, but we'll do the best we can. So 0 is 79.7, so that's going to be really close to 80. 1 is 82, so that's going to be a little bit up here. 2 is 85, so it's going to be a little bit above there. 3 is 88, and then 4 is 91. And then you're just going to kind of connect them. You guys, it's, again, because we don't have a grid and it's increasing slowly, you're probably not going to get that big, huge curve like we usually get. And you guys, try to make it as curve shaped as possible. Mine is probably not the best. But that's how you do it. Equation, table, graph. So you always, and the one that I gave you on your homework tonight, I want to say I don't think there's graphs, but I would like you to at least write the equation. Okay? Okay, so now what we're going to concentrate on, so that was growth. Yesterday was growth. Now what we're going to concentrate on is decay. And this time, what decay is when our B when that B is a fraction. It doesn't matter what A is. A just transforms. It's when the B is a fraction. When B is between 0 and 1, okay? That is when it's going to be a decay. We're going to treat it just like we treated a growth model. We're going to make a chart. We're going to graph. It's just that you have to be careful about the fraction. You guys, yesterday that we learned the K is what determines our asymptote, and it determines our range. So again, K is really what our asymptote is based on and our range is based on. So we're going to look at two questions. So we're going to flip over our notes and we're going to look at the first this first graph, and then we're going to do the last problem. So we're only going to look at graph 1. So just like we started out yesterday, we really started looking at what our A was. So what is our A in this problem? A is -3. So that means that our graph is going to start, it's going to start below the x-axis. What is our B? 2/5. That right there means that our model is going to be a declining, decreasing decay. What is our H? Remember from yesterday, if it says -4, what is it actually when we write it? It is +4. Good. And then what is our K? Right there, we already know our asymptote. Asymptote is a line which is y equals 2. So our K determines that. So we're just going to put that line in. That means that our graph, right, our exponential function is approaching 2. Because A is negative, it means it's going to be below it. Okay, so let me say that again. Because A is negative, our function is going to be below it. If A was positive, our function would be above it. But right now, our function is below it, so we're going to worry about that. So we're going to make a chart. Yesterday, I told you to start with the Fab 5. And the Fab 5 are -2, -1, 0, 1, and 2. So sometimes when you start with those, things don't go the way they want to. So I'm going to just, before I write everything, I'm just going to start with -2, and I'm going to see how it affects this problem. So I'm going to put it in, so we're going to do it like this. -3 times 2 divided by 5 raised, so here, right here, it's -2 minus 4. So my x is -2. Well, what is -2 minus 4? So you have to put in your exponent. Don't put in x minus 4. You actually need to do the math like in your head or before you do the problem. And then I'm going to add 2. And what did I get? -730. Is that anywhere on our graph? No. So this tells me that maybe my negative numbers are not good. So -2 is too high, so I want to go 0. So we're going to test 0. Notice I'm not writing anything down because I need you to test these before you start making a whole chart and you realize, well, that didn't work and that didn't work. Let's test them in our calculators first. -3 times 2 divided by 5. And now to get my exponent, I'm going to put in 0 for x. So what is 0 minus 4? Positive or negative? So I'm going to put -4 plus 2. Well, that still didn't work. So that was 0. Let's try 2, okay? 0 didn't work, so let's try 2. -3 times 2 divided by 5. And when I say let's try 2, I'm replacing the x with the 2. So what is 2 minus 4? -2. So I'm plugging, I plugged in regular 2 and I got -2. And then I'm going to add my 2. What did I get? Oh, I'm getting closer, right? So that's a little bit better. So we'll start with +3. This gave me -107.30. I'm like, nope, that didn't work. So we're going to start with 3. So now we're going to put 3 in for x. We'll put 4 in for x, 5 in for x. We'll do 6 and we'll do 7. 1, 2, 3, 4, 5. You should have at least 5 points. That will give you a good estimate. So now we're gonna plug in 3. And you guys remember when you plug in 3, it's 3 minus 4. It's 4 minus 4. So these numbers are going to be your exponent once you put them in. So these are the numbers you're putting in for x. So if I put 7, this would be 7 minus 4. So my exponent is +3. 6 minus 4 is 2. So my exponent would be 2. So did everyone get those numbers? Because tonight you'll have to do that. So now what we're going to do is we're going to, with the exception of -2, we're not graphing that because we can't. There's no -730 on the graph. So we're going to start with +3. So 3 is here, and we're going to go down to -5.5, which is in between this -6 and 5. Then 4, -1. I like that one because it's on a point, right? 5.8, so 0.8 is just kind of close to 1. 6 is 1.52, that's like in between 1 and 2. And then 1.8 is kind of close. And that's our function. Okay, our domain is the same for everyone, whether it's decay or growth. What is the domain? Now, remember I told you K sets our range. What do you notice? Is the range greater than 2 or less than 2? It's less than 2. Our K was 2, well that stops, right? That's the stopping point. So that means our Y's are going to be less than 2. Which you can tell, everything was less than 2. And then that's our final answer. So that's what you have to do tonight. You'll have to graph, state the domain, state the range. You guys, you don't necessarily have to tell me what the asymptote is, but you do need to put it on your graph. It is important that you put it on your graph. There any questions over that example? Anything you need me to go over? Okay, so this is the last graphing one. We're going to do another word problem. So we're gonna do this guided practice. You guys, all of your problems tonight have a rate in them, but when I typed this one up, I did not realize that it did not have a rate, and that's because it's part of another problem that I didn't read. So here's our rate. This is our rate. They're always going to give you a rate. I just forgot to type ours in. Okay. A cup of black tea contains about 68 milligrams of caffeine. Draw a graph to represent the amount of caffeine remaining in the body of an average teen after drinking a cup of black tea. Okay, so what clues me in that this is a decay model, besides the fact that it tells you in the guided practice that it's a decay model? You know they're not going to do that. How do I know that this one is a decay, decreasing? How do I know that? What gives it away? After drinking, what's another one? Dylan. Remaining. So those two say, hey, I need a decay model. So our decay model is this one. Notice it looks a lot like the growth model, but what's the difference? Amber. There's a subtraction sign. So if it says go and graph, I'm not going to make you graph it on the notes, but if this says go a graph, the first thing you're going to have to do is write that equation. So let's do it. A of t stays. What is our initial value? How much do we start off with? We start off with 68 milligrams of caffeine. 1 minus, well, what does R stand for? And what is our rate? 0.125, because you need to convert it to a decimal. That's what you would need to graph. Just like we did in the very first example of today. If it asks you to graph, you have to write an equation, make a chart. I'm not making you graph right now, but I am going to make you solve the next problem. The very last sentence says, estimate the amount of caffeine in the body 2 hours after drinking a cup of black tea. So now they're telling us, I need you to find the value when t equals 2. So we're going to write it out. And then you're going to put it into your calculator. So write it out. And let's see. So remember, this time, there's no subtracting to do because your exponent is just the t, which is 2. They gave it to us. How did we know? Because it says 2 hours. So We're going to hit enter. And did you guys get 52.0625? So we're going to round that to 52.1 milligrams. It's an estimating problem, so you need to change that equal to approximate. There any questions about how I did that or what you're expected to do tonight? So workbook, page 91 and 92, you're going to skip numbers 5 and 6 on page 91. And then there's some textbook problems that I need you to do that I think they're word problems, and I just want you, I think there's one graphing and the other ones you just have to set up. I just want you to set up the equation. Okay, it is 12:30.